Welcome to the Chapter 3 Part 1 video. This video will cover 3.1 and 3.2. So Chapter 3 is all about lines and angles and their special relationships. And we're going to start out by just talking about some of the relationships that you might have heard before, such as parallel lines and planes. So our first objective for this chapter is to identify relationships between figures in space. Now, in space, we're talking about 3 dimensions, and to identify angles formed by 2 lines and a transversal. And we'll talk about what a transversal is as well. So our first definition, parallel lines. Parallel lines have to be in the same plane, so they are coplanar. But they never intersect. So these are when we're looking at an XY coordinate, right? That's a plane, and parallel lines are lines in that plane that never intersect. And you may remember from algebra that that means they would have the same slope, but we're looking at it from a geometric point of view now. So if we look at our diagram here, we can pick any 2 lines that are on the same face, on the same plane, that never intersect. So this line here, AE, is parallel to the line here, BF, right? So I can say that AE is a line and it is parallel. So we do 2 lines, 2 vertical lines right next to each other means parallel to BF. Okay, now this word might be new. Skew is similar to parallel in that the lines will never intersect. However, the reason that they don't intersect is not because they're going in the same direction, but now it's because they are non-coplanar. They're not in the same plane. So these are 2 lines that are non-coplanar and never intersect. So if I look here at line AE again, even though line AD isn't in this front face, they do share the face on the left, right? They're both in that plane. So we want to find a line, and we'll use AE as our example, that doesn't share a plane with line AE. So it can't be on the front face and it can't be on the left face. So if we pick a line, for example, on the right face of this cube, so we have AE, it would be parallel to BF, it would be parallel to CG, they're going the same direction, but BC is a line that's never going to touch line AE, but they're not going the same direction. And that's what skew means. They're not going the same direction, but they still never touch. So AE, which is a line, is skew to line BC. Okay, our third definition here should be familiar. Parallel, meaning that they're going in the same direction, but now we're applying that to planes. So parallel planes, just like parallel lines, will never intersect. Okay, so parallel planes are planes that are going in the same direction. They're running in the same direction, but they're never going to touch. So an example here would be the left side and the right side of this cube, right? They're in the same direction, but they're never going to touch. And so we can say that plane ADE is parallel to plane here BCG. Okay, so how do I know if I'm talking about a parallel plane or a parallel line? Well, we have to look at what is parallel. So the symbol for parallel is the same, but if I've got 3 letters, that means it has to be a plane. And notice it also doesn't have a line over it. So this is talking about planes, whereas this is talking about lines. It has the notation for that being a line. So let's take a look at the try this. We want to look at the diagram here, the blue diagram here, and we want to say which segments are parallel to AB. So I'm going to go ahead and get a highlighter for this. And I'm going to start by highlighting AB. So this is AB. Now that motion that I did, that angle that I did on AB is going to be the same for all of the lines that are parallel to it, right? So if AB goes kind of this way, what other lines are going this way? Well, CD, GH, and EF. And if I look at all the other lines, they're not going in the same direction. Okay, so which segments are parallel to segment AB? We have segment CD or DC, segment GH or HG, and segment EF or FE. Okay, which segments are skew to CD? So now we're looking at, I'm going to use a different color. I have yellow here. Here is CD. I want it to be going a different direction and never touching it. So these are going different directions, but they do cross CD, right? So if we look at BC, it intersects, AD, it intersects. AB is going the same direction. And then these ones are also intersecting. So we want to look for BF is in a different direction and it never crosses. So BF is going to be one of our solutions. Okay, EF was parallel. What about AE? AE is in a different direction and it will never cross CD. So AE is skew. Okay, and then we have FG. FG will never cross CD and it's in a different direction. So here we have FG. And we have EH here is in a different direction and will never cross CD. So EH is also skew. Okay. The way I like to think about skew, parallel is going to be if I'm running down a hallway and you're running down a hallway, but it's on a different floor, or if it's a block over. Okay. So we're running in the same direction, but we aren't in the same place. So that's parallel. Skew is if I'm running perpendicularly to you, and it doesn't have to be perpendicular, right? If I'm running in a different direction than you, but we are on different floors of a building or we're in different city blocks, and therefore we're never going to cross paths. Okay, so parallel and skew both mean that you will never intersect. However, skew means you're in a different place. So you're not intersecting, not because you're running next to me, but because you're running on a different floor of the building or on a different city block. Okay. And then we want to list the pairs of parallel planes. And here it says 2, but there are actually 3. So I'm going to go ahead and list all 3. So we're going to look at the left side is parallel to the right side. So we have plane ABF is parallel to plane DCG. That's left and right. And then we have parallel to the bottom would be the top. So we have FEH is parallel to BAD. That was the bottom and the top. And then our last pair of parallel sides would be the front and the back. So we can say FEH is parallel to AB or BF. Oh, I did top and bottom. I'm doing front and back, not FEH. AEH is the front, and the back would be BFG. Almost did top and bottom twice, front and back. Okay, so we've got left and right make a parallel pair, the bottom and top make a parallel pair, and then the front and back make a parallel pair. Okay, so those are our definitions of geometric shapes that will never cross each other. They will never intersect. What if I have a line that does intersect? So a transversal is a line that passes through 2 or more distinct lines. So if I have 2 or 3 or more lines, and then I have a line that goes through all of them, that's called the transversal. Trans means across or change, verse, so it's going across a space. Like a universe, there's one space. This is going across the space. Okay, so we want to look at this transversal goes through lines A, B, and C. And I know I didn't leave you very much space, but there should be a little fill in the blank for an A there. Okay. So that's the transversal, goes across lines. And then we have corresponding. So when we have a transversal and we want to talk about spaces created by that transversal, we have this word corresponding, meaning it's in the same spot, right? This is the top right. And then we look at this other point of intersection, and it's also the top right. So corresponding means kind of if I were to look at this as an intersection, this is the top right, this is the top right. They're in the same place. Okay. Next, we want to talk about opposite sides of the transversal. So here's my transversal. We have the right side, or the right side and the left side of the transversal. And so those are opposite sides. Okay. We can also call them alternate sides. So we also call this alternate sides. If we say the same side, then we're talking about they're both on the right, or it could be that they're both on the left. So they are on the same side of, again, the transversal. And then we have interior, which this time, so these are describing sides of the transversal. This is talking about the lines that the transversal goes through. So the interior is between the two lines that this is the transversal. Between the two lines the transversal goes between. And then exterior is on the outside of those lines. Okay, now we are going to use combinations of these words in order to describe the place that we're referring to. And usually that means the angle. So if I was talking about this angle, that is an interior angle. And this angle is an interior angle. And because they're not on the same side of the transversal, I would say these are alternate or opposite side interior angles. So let's take a look at some of those ways we can describe angles. Let's start with, on number 3, we're using those terms, and it might help to keep that page in front of you. If you printed back to back, then have the PDF open so that you can keep looking at those vocabulary words that we're going to use. And we want to start out by looking at how we can compare angle 1 and angle 7. And the first thing we're going to do is say, are they on the same side or the alternate sides of the transversal? So here's our transversal. Are they on the same side or on opposite sides? They're on different sides. One's on the left, one's on the right. So this is going to be alternate. And then the second part is to say, are they on the inside of the lines or on the outside of the lines? So we're looking now at the lines that the transversal goes through. Are they on the inside or the outside? Now, angle 1 and 7 are on the outside of those lines, so they are alternate exterior angles. Alternate exterior angles. Let's look at angles 4 and 8. Angles 4 and 8 here. Okay, they're on the same side of the transversal, but they're also not both inside or outside. So they're on the same side of the transversal, but they're also both below the lines that the transversal crosses. And so we can say these are both down and left, so those are in the same spot. They are corresponding. Corresponding, they're both down and to the left of the points of intersection. Angles 3 and 5, they're on opposite sides of the transversal, and they are both inside of those lines. So they are alternate, opposite sides, interior, because they're inside. So these are alternate interior angles. 5 and 7, this one should be familiar, right? 5 and 7, are vertical angles. 4 and 5, they're on the same side of the transversal and they're on the interior. So these are same side, interior angles. And just like instead of saying opposite sides, we say alternate, if we wanted to use a single word to talk about same side, we use the word consecutive. Consecutive interior angles. Okay, so you'll see it called both things, same side interior or consecutive interior angles. So let's try these with a diagram. Okay. Name a pair of alternate interior angles. So first we need to identify which one is the transversal. The transversal is the one that goes through multiple lines. And so this here is going to be our transversal. Now, a helpful tip that I find in order to find out alternate interior, exterior, I like to draw a Z, okay? So I make the Z along the transversal. So I'm going to go along one of the lines, down the transversal, and across the other line, okay? This is going to be particularly helpful when we start talking about parallel lines. But this kind of helps me identify, there's the transversal that I'm talking about, same side or opposite side. So our first one, alternate, I want it on both sides. Interior, inside of my two lines. So which of these angles could be alternate interior? Well, opposite sides on the inside, there's 2 and 6. So angle 2 and angle 6. Or we could go opposite side interior could be 3 and 7. Angle 3 and angle 7. Name a pair of corresponding angles. Now there are 4 pairs of corresponding angles here. I can say, looking at these points of intersection, I can go up to the left, that would be 1 and 3. Angle 1 and angle 3, which are this up and to the left angle. And then we can say up and to the right would be angle 2 and angle 4, which is in this position, up and to the right. And then I can say down and to the left would be angle 8 and angle 6. And then our last pair of corresponding angles would be angle 7 and angle 5. Okay, now the diagram I'm putting is not part of naming the angles, it's just showing you how did I get those two numbers? How did I get those two angles? Those were both the angles that when I look at the points of intersection, I looked up and to the left, angles 1 and 3. Now, part 3, name a pair of same side interior angles. Okay, so that tells me I want them to be on the same side of the transversal, but on the inside of those two lines. So that's going to be angle 2 and angle 3, or we can say the other side of the transversal on the inside would be angle 6 and angle 7. Name a pair of alternate, opposite side, exterior angles. So opposite side on the outside of those two lines. So again, we have outside of the lines on opposite sides. So we have 1 and 5, and we have 4 and 8. So angle 1 and angle 5, or you could use angle 4 and angle 8. A pair of vertical angles. We have 4 pairs of vertical angles here. Vertical angles, same definition that we used before. So that's angle 1 and angle 7, angle 2 and angle 8, angle 3 and angle 5, angle 4 and angle 6. And a linear pair, we need to recall what a linear pair is. A linear pair is 2 angles that are together on the same line and adjacent. So they add up to 180, they're supplementary angles. They should definitely be adjacent. So angle 1 and angle 7 are not a linear pair. Angle 1 makes a linear pair with angle 2. Or you could say angle 1 and angle 8 make a linear pair. So we have many linear pairs here. We have angle 1 and angle 2. We have angle 1 and angle 8. We could do angle 8 and angle 7, or angle 7 and angle 2. And then we also have linear pairs on our other point of intersection, angle 3 and angle 4, angle 4 and angle 5, angle 5 and angle 6, or angle 6 and angle 3. Okay, so all of those are options for a linear pair. Okay, now for section 2, we're looking at this same concept with transversals, but we're putting specifically the special case of if those two lines were parallel. So let's take a look at section 2. And the first thing we want to do is remember that what it means to be parallel is that these two lines will never intersect, right? They have the same slope, and so they create the same angles. And we're going to talk about those special angles. So our objectives for this section are to prove theorems about parallel lines. So we're going to bring proofs back. That's why you started them over the weekend. And then we're also going to use properties of parallel lines in order to find angle measurements. Okay? So if we're looking at parallel lines, the way we tell that they're parallel is we can mark them with little arrows. So if you see little arrows on the inside of the lines, one arrow on each line means that those two lines are parallel. And just like with segments or angles, if we have multiple pairs of parallel lines, we can use a different number of little arrows or triangles in order to represent that they're parallel. So for example, I could put 2 arrows here, and that still means that those two lines are parallel. Okay, now they can be facing any direction. They don't even have to be right next to each other like that, but they should be facing the same direction. So for example, I would want the parallel lines to have arrows facing the same direction every time. And that's how we can tell by a diagram when lines are parallel. Do not assume lines are parallel unless you're told so, or it has the little marking. So just like consecutive angles or congruent angles or congruent segments, we don't want to assume it. We want to actually look for the markings on the diagram. Okay? So we're going to do some practice, and this is how we're going to fill in the diagrams. We're going to say, if lines are parallel, then what type of angles are given are, and then if they're congruent or supplementary. So how do we know if they're congruent or supplementary? Well, corresponding angles, notice these are both up and to the left, corresponding angles are congruent. They have equal measurements. Alternate, opposite sides of the transversal, interior, so alternate interior angles are congruent. Alternate exterior angles are also congruent. Same side interior, or remember we could call this consecutive interior angles, are supplementary. And we already know that vertical angles are congruent and linear pairs are supplementary. So let's take a look at the practice problems. So in this example, we want to find the value of x if possible, and we're using those properties of the transversal and parallel lines in order to find these values. So first we need to determine, are these lines parallel? And we're not going to assume that they're parallel, but we need to know if those two lines are parallel. Because they have the little arrow, the little triangle marking, we know that they're parallel. If the lines are parallel, then okay, so what type of angles are these? Well, they are on opposite sides of the transversal. Here's our transversal. And they're on the outside of our two parallel lines. So these are alternate exterior angles. Alternate exterior angles. And we said alternate exterior angles are congruent. Which ones are supplementary? Supplementary are the consecutive interior or the linear pairs. Okay. Part B. Since the lines are, so the question is, are the lines parallel? We have nothing that says that they're parallel. We also have nothing that says that they aren't parallel. Even though they don't look parallel, we cannot assume that they're parallel. So since the lines are not parallel, meaning that they don't have to be parallel, then these are called consecutive angles are not congruent. Sorry, not supplementary. Right? Consecutive angles could be supplementary. They're on the same side of the transversal, so that is kind of the hint that they might be supplementary. Just like a linear pair on the same side of a line. Okay, part C, given that line K is parallel to line J, so we know that K is parallel to J, we can go ahead and mark it on our diagram. If the lines are, we were told that they're parallel, so these are parallel. Then what type of angles are these? Well, they're on the same side of the transversal, but they're also both on the same side of their own parallel line. So this is up and to the left, so they are corresponding. The corresponding angles are congruent. Okay, and then we said we also wanted to find the value of x. So going back to our first example, we said these are congruent. So if these are congruent, then x equals 30. We cannot tell from part B. We don't have enough information to finish that. And then part C, we said they are congruent. So x equals 100. Let's take a look at example 2. In example 2, we know that the measure of angle 3 is 55 degrees. As soon as I know it, I'm going to mark it on my diagram. Which angles are supplementary to angle 3, and how do you know? So how do we find supplementary angles? Well, we know that angle 1 and 3 are vertical. If they're vertical, are they supplementary? No, vertical angles are congruent. That means angle 1 is also 55 degrees. So which angles are supplementary? Well, 2 and 3 make a linear pair. That means that angle 2 and 3 are supplementary. So angle 2 by linear pair. What other angles are supplementary? Angle 4 also makes a linear pair. So angle 4 is also supplementary by linear pair. Okay. Can we say anything about these other angles? Well, in order to say anything about these other angles, I first need to know that the two lines are parallel. We do know that they're parallel. So then we know that angle 3 and 8 are consecutive angles, which are also supplementary. Right? So angle 8 is supplementary by consecutive or same side interior angles. What about angle 5? Is angle 5 supplementary with angle 3? Those are alternate interior angles. That means they are congruent. Okay. Angle 3 and angle 7 are corresponding angles, which are congruent. And angle 3 with angle 6 does not have a special name. However, we know that angle 3 and 8 are supplementary, and we know that angle 8 and 6 are congruent. And therefore, angle 6 is also supplementary to angle 3 by congruency, congruent to angle 8, which is consecutive. So that one took 2 steps in order to say that it was supplementary. So we marked already here all of our congruent angles. What is the value of our supplementary angles? What's the angle measure? Well, we have 180 minus 55 gives us 125. And that tells me that all 4 of these remaining angles are 125 degrees. And so we can see here that when we have parallel lines with a transversal, all 8 angles are going to be one of 2 measures. It's going to be an acute angle or an obtuse angle. And all of the acute angles are congruent. All of the obtuse angles are congruent. There is a special case where if one of these angles is 90 degrees, then we won't have acute and obtuse. But we'll see later on that that means that all 8 angles have to be 90 degrees. So let's take a look at some more examples. In example 3, we want to identify the types of angles. So part 1, if M is parallel to N, we absolutely have to know that if we wanted to solve for anything, right? So M is parallel to N. I'm going to put the little arrows. Notice I'm not putting it on the very end because that would just represent a ray or a line. So here I'm putting it on the inside of the line so that I can tell that it means that they're parallel. So we want to find the value of X and we want to say the reason. Well, let's start with the reason. We have parallel lines, so we know that these 2 angles are corresponding. And corresponding angles are they supplementary or congruent? Corresponding angles are congruent. I'm going to use the congruency symbol. So if these 2 angles are congruent, then 72 equals X plus 2 minus 2. 70 equals X. We're going to do something similar for number 2. So for number 2, we want to solve for W and we want to say why we know that. Okay. Now remember I mentioned the Z that helps us with parallel lines. I'm going to start adding the Z onto these diagrams. Okay. So if we look at number 1, where would the Z be? Well, remember the transversal is the long part of the Z, and we put the other parts of the Z along the parallel lines. So we're going to do the same thing here. I'm going to say, here are my parallel lines, transversal parallel lines. Now the purpose of the Z is to help us identify where which lines we're looking at. And as we go through the notes, it's going to become clearer why that's important. Okay, so we have parallel lines. What's the relationship of these 2 angles? They are alternate, opposite sides of the transversal, alternate, and they are on the outside. They're outside of my Z. Alternate exterior angles. And our alternate exterior angles supplementary or congruent? They are congruent. And so we have 3W equals 51. Divide both sides by 3. W equals 17. Let's look at number 3. Find G and explain. So we're doing the same steps, but it's slightly less scaffolding, meaning less instruction. Okay. So again, I'm making this a habit. I'm going to write my Z. Now this is going to be a backward Z, just so that I can make my Z always the acute angle. You don't have to do that, but I do think it makes it clearer when it actually looks like a Z shape. Okay. So I'm going to start by saying what's the relationship of those 2 angles? They are vertical angles, and vertical angles are congruent. Now vertical angles are congruent even if these 2 lines are not parallel. Notice it's only really using one of those intersections. It's not using both. So vertical angles are congruent, which means that I can say G minus 9 equals 128. Add 9 on both sides. G equals 137. On number 4, now this is a little bit more difficult to see because in all of these, our lines are extending past the point of intersection. And so what we can do is we can just extend our lines past these points of intersection so that we can see what's going on. Okay, now my variables are here. So I'm going to make my z over here. And what that helps me do is it helps me see what is important, right? What is it that I actually need to get from the information on this diagram? And what's happening is I actually don't need this other transversal in order to solve this, this problem. So we want to find the value of x. I'm going to say these two angles are consecutive or same side interior. So parallel lines, and they are consecutive, which means they are supplementary. And supplementary means they add up to 180. So I can say x plus x minus 50 equals 180. 2x minus 50 equals, minus 50 equals 180, plus 50, plus 50. 2x equals 230. Divide both sides by 2. X equals 115. So this is one example of why the z is helpful. It shows you what information do you need to use and what information is extra or extraneous. We don't need it. Let's keep going. Number 5. Okay. So we know that lines A and B are parallel. I'm going to mark that on my diagram here. A and B are parallel. Find the value of f and explain. So here we go with my z. And that tells me that these are the two angles that I need, and they are consecutive angles. So parallel lines, consecutive angles means supplementary. And so we have 4f plus 2 plus 98 equals 180. 4f plus 100 equals 180 minus 100. 4f equals 80. Divide both sides by 4. F equals 20. And our last one for this page, find z and explain. I'm going to write my z. And that shows me these are on opposite sides of the transversal on the inside of my z. And so these are parallel lines with alternate interior angles, which are congruent. And so we can say 6z plus 28 equals 12z minus 8 minus 6z plus 8. And so we have 36 equals 6z. Divide by 6. 6 equals z. I'll rewrite it up here just to write z first. It doesn't have to be first by any means. You could leave it like this. That's just for clarity. Okay. Let's look at our last couple of examples on the next page. Normally we would do this as group work in class, but since we can't do group work during our asynchronous time, this is going to be classwork. I'll walk you through them, but make sure you're following along. I'll give you time. I pause so that you can think through it before I give you the answer. So, number 1, find the value of x and explain. First thing I'm going to do, I said these are parallel, so I'm going to draw my z. And I recognize that these are corresponding angles. So these are parallel lines, and you don't have to write this every time, but I want to make sure that you recognize that these properties only work for parallel lines. the lines are not parallel, then we do not have these same congruencies. So parallel lines and corresponding, which I'll abbreviate, angles, which means they are congruent. So 15x minus 5 equals 13x plus 5. Solving for x, subtract 13x from both sides, add 5 to both sides. This is an example of why it's really important to write out your work. There is a huge temptation to cancel out the 5s on both sides, but they are opposite signs, so that does not happen. So we have here 15 minus 13 is 2x equals 10. Divide by 2, x equals 5. In number 2, M is parallel to P. Here's my Z. Here are my parallel marks. Okay, measure of angle 1 is 5 times the quantity of 2x squared plus 1. Measure of angle 2 is 7x squared plus 17. Don't let that scare you. We're doing exactly the same thing as we just did in example 1. So first I need to know what's the relationship between these angles. They are alternate exterior angles. So parallel lines and alternate exterior angles are they supplementary or congruent? They are congruent. And so we can set them equal to each other. 5 times 2x squared plus 1 equals 7x squared plus 17. Let's distribute this 5. So we have 10x squared plus 5 equals 7x squared plus 17 minus 7x squared minus 5. 10 minus 7 is 3x squared equals 17 minus 5 is 12. Divide by 3, x squared equals 4. Now in order to find, notice it's not asking for the value of x. This is find the measure of angle 2. In order to find the measure of angle 2, I can substitute x squared. I don't actually need the value of x. And so we can say the measure of angle 2 equals 7x squared plus 17. And we're going to replace the whole x squared with 4. 7 times 4 is 28 plus 17 equals 45 degrees. Okay, number 3, find the value of x and explain. So we're looking at these two angles. They are alternate, but they're not both on the exterior. They're also not both on the interior. They're not corresponding. So there's no special relationship here. No special relationship. However, but we can still solve. How can we still solve? Well, I know other relationships, right? So I can say 3x minus 7 is congruent to this vertical angle. I can name that 3x minus 7. And so now they do have a special relationship. So if we use vertical angles, now we have corresponding angles on parallel lines, which means they are supplementary. So supplement. So 3x minus 7 plus x plus 5 equals 180. Collecting like terms here, 4x minus 2 equals 180, plus 2, plus 2, 4x equals 182, divided by 4, x equals 182 divided by 4. It doesn't go in evenly, 45.5 degrees. Okay, number 4, find the values of x and y and explain for each. We will be using some of the space underneath these boxes, just a little bit. So here, we have to choose which variable do we want to solve for first. And I'm looking at this. This equation uses x and y, but these two have just x. And so if I use these two angles here, I can solve for x first pretty easily without using systems of equations from algebra. And so let's solve for x first. So we have to know what is the relationship between those angles. I'm going to write my z here. I didn't write a z on the last one, but if I wrote my z, it would be there. And it is a good habit to get into. Okay, so there's my z. How do I describe these angles? Well, they are alternate exterior angles. So alternate exterior angles. And alternate exterior angles are congruent. So we have 3x plus 10 equals 4x minus 8. Solving for x, minus 3x on both sides, plus 8 to both sides. So we have 18 equals 4 minus 3 is 1, or just x. X is 18. And then, now that we have x equals 18, we need some other relationship. So I can talk about these two angles, but there's no special name for that. We could call them same side exterior, but we don't have a relationship for same side exterior. They happen to be supplementary, but we haven't really talked about that yet. We do have vocabulary and some practice with looking at these two as a linear pair. So either way, you can absolutely do either relationship. I'm going to use the one that we've already talked about extensively. So linear pair are supplementary, which means 3x plus 10 plus 11x plus 2y equals 180. But we already know that x is 18. So we can say this is 3 times 18 plus 10 plus 11 times 18 plus 2y equals 180. And I'm going to put that whole thing in my calculator. So we have 3 times 18 plus 10 plus 11 times 18. Enter, 262. So you can say this is 262 plus 2y equals 180 minus 262. 2y equals negative 82. Divide by 2. Y equals negative 41. So there's y and there's x. Now, if we're talking about angle measures, how come y can be negative? Well, notice y is not an angle measure. Y is part of the calculation for the angle measure. Okay, so these angles will all still be positive. If you wanted to double check, we could substitute in 11 times 18 plus 2 times negative. Make sure you're using the negative is down here, negative 41. Enter. Is still positive, 116 degrees. Okay, you didn't have to do that as part of the problem, but I did want to point out that you can get variables with negative answers. You should not have angles with negative values, though. The measurement of an angle should be positive for this class. Okay, our last problem here. Assuming that J and K are parallel, so I'm going to go ahead and mark these as parallel. Write two equations that can be used to find the value of x. Notice it does not say to solve for x. We're just writing the equations and explaining how we got them. Okay, so we need two relationships. The first relationship that we could use, I see as a linear pair. So we can say linear pair. We can say 18x plus 2 plus x plus 5 equals 180. We just have to write the equation and explain where it comes from. We do not have to solve this one. Our second relationship that I can see from these angles is corresponding angles. Corresponding gives us congruent angles. So 18x plus 2 equals 20x minus 16. And that's all we have to do for that one, is to set up the equations. Okay, I want to make sure that you understand this. We'll have plenty more practice in class, but make sure that when you're going through these notes that you really understand the steps and the process behind all of these. I'll go ahead and draw in the Z here. And you'll see on the practice how helpful that Z can be.